Hey everybody in Econ 1B land. Today I'm going to go over the participation activity market forces of supply and demand. We did this in class, we did this in lecture, but I noticed a lot of people are commenting that they're still not 100% on how to derive these graphs and what shifts supply, what shifts demand. So we'll do a quick review of it, and that way if you need another reference, it's standalone right there for you to take a look at. So let's get started. Okay, so here we have our problem. We have a world with two people who both consume tacos. We have their individual demand schedule. So at every price, we have Sheila's demand for tacos and Nate's demand for tacos. And the first thing we want to do is remember that to get market demand, we need to sum up all the individuals in the market. So if we had 100 people, we would add up each of those 100 people's demand at every price. But here we only have two people, Sheila and Nate. And at $0, Sheila demands 10 tacos, Nate demands 11, so that gives us a market demand of 25. At $1, Sheila demands 8, Nate demands 12, that gives us a market demand of 20. At $2, we have a market demand of 15. $3, 4 plus 6 is 10. Then it goes down to 5, and then at $5, Sheila demands 1 taco, Nate doesn't want any, so market demand is just that one. So that is the market demand for our little market of tacos. So far, so good? So now what I want to do is go to part 2, tells us about the supply of tacos. And in this case, we don't have to add up each individual supplier, we just have it given. So the market is willing and able to supply 30 tacos at $5, 25 tacos at $4, 20 tacos at $3, 15 tacos at $2, and 10 tacos at $1. So I'm going to go ahead and write that up here. I'm going to put my market supply up here next to my demand so I can keep track of it. So at $0, the market is going to supply 0 tacos. At $1, 10. At $2, 15. At $3, 20. At $4, 25. And at $5, 30. And we see that the supply schedule and the demand schedule both obey the law of supply and the law of demand, respectively. So now we want to go down here and draw the supply and demand curve and determine what our equilibrium is. So here's my price and quantity on my X and Y axis. And I have prices of $5. Oh, that doesn't work. There we go. All right. I have $1, $2, $3, $4, and $5. And then I have 5 tacos, 10 tacos, 15 tacos, 20 tacos, 25, and 30. And I can go ahead and graph market demand and market supply to get my demand and supply curve. So at $0, the market is going to demand 25 tacos. At $1, the market will demand 20 tacos. At $2, the market will demand 15 tacos. At $3, we get 10. And then at $4, it goes all the way down to 5 tacos. And then at $5, we're going to say that that's 1 taco there. Okay, so now I have my demand curve when I add those points up. And you get to choose how precise you are with these things. I think it's good to graph each individual point a couple of times, but a lot of these curves can be drawn without a lot of detail. You can still get a lot of the same information without a lot of detail. Now I want to go ahead and get my supply curve in. So my supply curve is going to start with 0 tacos at $0. And then at $1, the market will supply 10 tacos. At $2, the market will supply 15 tacos. At $3, the market will supply 20, $4, 25, and at $5, the market will supply 30. So now I have an upward sloping supply curve and a downward sloping demand curve. To find my equilibrium price and quantity, I can do a couple of different things. The first is I can see where quantity supplied is equal to quantity demanded. It's right here, right? Supply is equal to demand at 15 tacos and a price of $3. But you can also see it up here in the supply and demand schedule. Market demand is falling. Market supply is rising as prices go up, and they meet in the middle at a quantity of 15. So I know that these two curves are going to be equal to each other when quantity demanded is equal to quantity supplied at a price of $2. So I might want to write a little note to that effect or just remind myself that my equilibrium price is $2 and quantity is 15 tacos. So that's part 2. Now for part 3, we get asked what would happen if the price of tacos were set at $3? What would happen to the market? Well, we can look at it here on our graph. If the price were set to $3, quantity demanded would be 10 and quantity supplied would be 20. We can also see that up here, right? At a price of $3, the market demands only 10 tacos and supplies 20. We in economics would call that a surplus. So at a price of $3, quantity demanded would equal 10 tacos and quantity supplied would equal 20 tacos. The market would have a surplus of 10 tacos, and we would all be better off at the equilibrium price of $2. Cool? The next question says, imagine the price of burritos goes up. How would this affect the market if you consider burritos to be complements to tacos? How would this affect the market if you consider burritos to be substitutes to tacos? Draw the effect of burritos as substitutes and label it as number 2. So I'm going to go ahead and do both. You don't have to, but I think it's kind of a useful exercise. So I'm going to get some interesting colored pens out here to make it a little bit more fun for me. And I'm going to say, okay, if burritos are substitutes, an increase in the price of burritos is going to shift demand for tacos out, right? Because if burritos and tacos are substitutes, I'm choosing between eating a burrito or a taco. If price of burritos goes up, tacos seem relatively less expensive, relatively more affordable. And so the demand curve is going to shift out to a new higher level. I'm going to call that demand 2. And remember, that's because prices of related goods are non-price determinants of demand, and so we'll see that effect. So we'll see the demand curve for tacos shift out, shift to the right, and that's going to mean that there is a higher quantity demanded for tacos at every price, right? But I can also do the other, right? I can do the opposite. So what if we see the price of burritos goes up and burritos are complements? If you want to eat burritos and tacos together, and now burritos are more expensive, the experience of buying tacos and burritos together has gotten more expensive. And so you're going to see a change in demand for tacos the other direction. Demand for tacos would decrease. You'd see the demand curve shift in, and you'd see a decrease in the quantity demanded for tacos at every price. We also want to look at the equilibrium effect. So with demand too, if burritos are substitutes and burritos get more expensive, tacos get more affordable, we're going to see the equilibrium price go up and the equilibrium quantity go up, right? Well, that pen's not working. We're going to see an increase in P star, our equilibrium price, and an increase in our equilibrium quantity. On the other hand, if demand goes down, we'll see a decrease in the equilibrium price and a decrease in the equilibrium quantity. And the two things I want to remind you of here are, first of all, to remember to talk about the demand curve shifting as either out or to the right, and the supply curve shifting out or to the right, and shifting in and to the left, because up and down can get confusing, especially when you're working with the supply curve. And then to remember to look at where your new equilibrium is. So in this case, if we have demand shift because burritos have gotten more expensive and they're a substitute for tacos, our new equilibrium is our new demand curve and our original supply curve. What if we had an effect on supply and an effect on demand all at the same time? Well, luckily, the last part, part 5, asks us about that. It says, what would happen if there was an increase in the technology used to make burritos? How would that affect your market? So we can go ahead and take a look at that by drawing the effect. And so you want to remember, first of all, that a change in technology is going to be a supply side effect, right? It's going to shift the supply curve, making it more affordable to consume and produce burritos, or more affordable to produce burritos, more affordable to make burritos. So let's get another pen color. And so we're going to say an increase. Let's get a different one. That doesn't really show up. Sorry. An increase in technology is going to make it cheaper to produce burritos. That's going to shift the supply curve out for tacos, right? Now it's cheaper to make tacos. Firms are going to make more tacos at every price. We want to think about supply curve shifting out or to the right, because otherwise we're talking about supply shifting down, and that's not what we want to see. It doesn't really make sense intuitively. So if we shift that supply curve out, we're going to get a new supply curve. We'll label that supply 2. And now we see that happen because new technology makes it cheaper and easier for firms to produce tacos. We now have a new equilibrium here on our demand curve and our supply curve. And if it's confusing, it's because I drew a bunch of curves, right? I didn't have to draw this D3. That was just a bonus. But if both things happened, if we see the price of burritos go up and burritos are a substitute, we'll end up with D2. And then a change in technology means we'll end up with S2. And so that means we're going to have some new equilibrium where the quantity is higher and the price, in my case, is actually the same. I've moved it back out to price 2, but that's that ambiguous outcome you could get depending on how far you shift your curves. Okay? So hopefully that makes sense. Hopefully that helps you understand how this problem works. I'm going to post an answer key too. If you have any questions, if you want to go over one of the homework problems, let me know. Otherwise, I'll see you next time.